Okay, so let's have a look at a tougher rates of change question. Now, this one is sand is being poured onto a top of a pile at a rate of 4 meters cubed per minute. The pile always remains in the same shape of the cone with a semi-vertical angle of 45 degrees. Find the rate at which the height, A, and B, the base area, is changing when the height is 2 meters. Okay? So, we're looking for rates. So that's our dv/dr and dr/dx, because we're using our radius, and we're going to be using t, I should say, not d. So it should be dv/dr and dr/dt for the time that it takes as well. So let's draw a picture of what is happening. So sand is being poured on top of a pile. So the sand comes down and it remains in the shape of a cone. So when it falls down into this pile, it makes a conical shape like this. Now, what we know about this shape is that we've got a height, h, and we've got a radius, r, like this. And that would make 90 degrees there. And this is the center. Okay, let's call this top peak A and this side peak here B. Now, we also know that the semi-vertical angle is 45 degrees. So the semi-vertical angle is this angle at the top here. Okay, so this is our 45 degrees. So if that height there is 45 degrees, it must mean that we have an isosceles triangle, which means that our radius must be the same as our height. Okay, and so when the radius increases, the height also increases as well, and it's by the same amount to keep that 45 degrees there. Okay, the rate of change of volume is known to be dv dt. So dv dt is equal to, I'm going to do this in black actually, dv dt is equal to, and that's 4 for the 4 meters cubed per minute. Okay, because the volume is changing with respect to time up here. Okay, so part A says the height. So we know that the volume of a cone is equal to 1/3 pi r squared h. Okay, but because we also know that the radius is the same as the height, or r is equal to h, we can rewrite this as, and I should write but, we can rewrite this as 1/3 pi r squared r, or v is equal to 1/3 pi r cubed. Okay, and this is our volume with respect to our radius. So the radius is changing with respect to that. Actually, we're asked to find height, so we might actually do the conversion the other way. So instead of doing 1/3 pi, so it'd be 1/3 pi h squared h, which is the same as cube. Now the reason I'm picking h is because we want the height, and the height we've labelled h, so we'll do it this way, so dv dh. So differentiating with respect to time, dv dt, which we do know, is the same as dv dh times dh dt. So again, what this says is the volume is changing with respect to time by the fact that the volume changes with the height, and as the height changes with time, okay? Because we know something about this rate, and we know something about this rate, sorry, not that rate, or, yeah, that rate, and we're wanting to find something about this rate. We're wanting to find out which the height is changing, okay? So we know the height is changing with respect to time. We know this. We know this one. We know this one, and we don't know this one. And we want to know when the height is changing. Okay, or the rate the height is changing. So the height is changing with due to time. Okay, so dv dt. So we know what dv dt is. Dv dt is equal to 4. So over here I'm going to write dv dt is equal to 4. Okay, so we know dv dt is equal to 4, and we know what dv dh is because what we can do is we can say, well, we know that v is equal to 1/3 pi h cubed, so that means that dv dh, so differentiating v with respect to the h value, is equal to 3 times 1/3 pi h squared, or pi h squared. Okay, and so that is our thing. So let's substitute these values in. So dv dt is equal to 4, and that's equal to pi h squared dh dt. Now what we want to do for part A, for our first part, is again we want to be looking for the rate at which the height changes with respect to time. So what we're going to be doing is we're going to be substituting some values in. And the first value we're going to substitute in is the h is equal to 2, because we want to find it when it is changing, when the height is equal to 2 meters. So when h is equal to 2, the rate at which the sand is being increased, or it's increasing at, is equal to, so 4 is equal to pi times 2 squared times dh dt. So that means dh dt is equal to 4 over 4 pi, which is the same as 1 over pi. So dh dt is equal to, and we're going to plug this one into our calculator, 1 over pi, and we'll go to 3 decimal places, so 0.318. And that is our meters per minute. Okay, now we know it's meters per minute, okay, because all of our measurements are in meters and our time is measured in minutes. Now our next one is our base area. So our base area, so what shape do we have for our base area? And I'm hoping you keen punters at home have picked up that it is a circle. So our circle's base area, so part B, our circle's base area is equal to pi r squared. And because r is equal to h, this is the same as writing a is equal to pi h squared. Now remember, we want to keep it h because we're doing dh dt in our chain rule. So our chain rule becomes the area with respect to time, because that's what we're trying to find. We're trying to calculate the area with respect to time. Okay, is equal to dA dh, so our area changing with our height, times by our height changing with our area, due to time. So what we can do now is we can substitute the values that we know. So we know that dA dh, okay, so if this is a up here with respect to h, then dA dh is equal to 2 pi h, and we know that dh dt is again equal to this 2 meters because it's the height is changing. So this is dh dt over here. So all right, here dh dt is equal to 2. What we can do is we can just substitute these values straight in, and we're going to get dA dh, which is 2 pi h, times dh dt, which is 2. So that's 4 pi h. Okay, and 4 pi h. And we also know that, I should have also mentioned before we did this step, started to get ahead of myself, 2 pi h times 2, sorry, that part's fine, but we know that h is equal to 2, okay? So remember, that's what our height is. Oh, sorry, that's the change in the height, isn't it? So our height is what we need to find. Okay, so we need to actually work out what the height is at that point. So how do we find what the height is at that point? Well, what we can do is we can substitute it into our area formula, okay? And our area formula says, well, it needs to be equal to, no, let me think. Oh, we worked this out before in our previous question. So dh dt was equal to 0.318, or also 1 over pi. So what we can do is our dh dt is equal to 1 over pi. And that's from question A. So it's 2 pi times 1 on pi times 2. So dA dt is equal to, so this one cancels with this one, so dA dt is equal to 4 meters squared per minute. So that's the rate at which the area is changing. So that area is increasing at a rate of 4 meters squared per minute when the height, so when this height here of this cone, so that height there, is equal to 2 meters. So last question was a little bit tricky, but it's all pretty straightforward calculus. You've just got to essentially be looking out for your, dA dt. So we're differentiating a with respect to t. So we need dA dH, so we need that, and dH dt, well, we can work that out from our values. And then our h values from dH dt, so it's equal to 1 on pi. So I just don't think that's quite right. So when h is equal to 2, I just don't know if that's exactly right. Oh no, because it was dH dt that we're substituting in the back, which is our 1 on pi, and we're doing it at time 2. So our time, our height was when it was at 2. So our h should technically be 2, and so it's just a matter of swapping these ones around. So it should be times 1 on pi, and then that cancels out with that. That makes it a bit more clearer. Yeah, so height is when it's at 2, because we know the height is at 2 meters from up here. That makes more sense. Okay, cool. So with that being said, that's the end of that question, and that's going to be the end of this little series of videos. I'll leave you guys to it. We're going to be having a look at some exponential growth and decay, though, in our upcoming one. So I'll talk to you guys in that one.